Here, we're going to look at some homework problems from section 7.1, where we start to look at confidence intervals. This first one, number 7, just make sure that we understand what's given to us in a problem and can identify it. If we look at this, it says a newspaper provided a snapshot illustrating poll results from 1,910 professionals who interview job applicants. The illustration showed that 26% of them said that the biggest interview turnoff is that the applicant did not make an effort to learn about the job or company. The margin of error was given as plus or minus 3 percentage points. What important feature of the poll was omitted? So if we look through the numbers that they do give us, they give us this 1,910 professionals. That's the sample size. Then they tell us it showed that 26% of them told us the biggest interview turnoff was that they didn't make an effort to learn about the job or the company. That's our point estimate. The other thing they told us about was the margin of error. So while they didn't directly give us the confidence interval or the confidence level, we can figure out the confidence interval from that margin of error. Remember, to do that, we take our point estimate plus or minus that margin of error. So we'd have 26 plus 3, which would give us our 29%, and we do 26 minus 3, which gives us our 23%. So we could say that our confidence interval was 23%, was less than our population proportion, which was less than 29%. So the only thing that's missing is the confidence level. Remember, that's the thing that's normally 95% or 99% or sometimes 90% that they have to tell us. If we look at this next one, it was number 9, and once again, they were asking us to identify some important things. So they told us a magazine provided results from a poll of 500 adults who were asked to identify their favorite pie. Among the 500 respondents, 12% chose chocolate pie, and the margin of error was given as plus or minus 5 percentage points. What values do P hat, Q hat, N, E, and P represent? And then if the confidence level is 99%, what is the value of A? So for this one, they weren't actually asking us to do any math. They wanted to make sure that we understood the notation. So anything with that hat is what's telling us that it comes from the sample. So P hat is the sample proportion. And Q hat is essentially the complement of that. It's 1 minus our P hat. Think back to the binomial where we had success and failure. It's very similar to that. N is our sample size. E is the margin of error. And P is the population proportion. Right, because it doesn't have the hat, we know it's from the population. So if we look at this problem and try to align the numbers to it, if they told us the poll was 500 adults, that's our sample size. They told us 12% of them chose chocolate pie, so our sample proportion would be 0.12, that 12% in decimal form. Our Q hat is 1 minus that 0.12, or 0.88. The margin of error is that plus or minus 5 percentage points. And then they don't give us the population proportion in the problem. The other thing that they ask us for is, if the confidence level is 99%, what's our value of alpha? So remember, we can think of this confidence level, 99%, as 0.99 in decimal form. The alpha is essentially the complement of that. We do 1 minus our 0.99, and that gives us 0.01. So our alpha level is 0.01. Now let's look at an example where they actually ask us to find a few things. So they're asking us to use the sample data and confidence level to complete these parts A through D. A research institute poll asked the respondents if they felt vulnerable to identity theft. In the poll, N, equals 946 and X equals 542 who said yes. Use a 95% confidence level. The first thing they do is they ask us to find the best point estimate of the population proportion P. When they're asking us for the best point estimate for a proportion, it is just P hat. So to find that, we look at our X divided by our N, the people that said yes, over the total sample size. So in this case, it's 542 over 946, which gives us 0.5729386892. They told us to round to 3 decimal places. That 9 tells us to bump that 2 up. So we have about 0.573 as our best point estimate as our P hat. If we look at part B, it says identify the value of the margin of error, round to 3 decimal places as needed. So this one, they give us the formula on our formula sheet. Our margin of error is our critical value, Z alpha over 2, times the square root of P hat times Q hat over N. So the good news is we already know P hat. It's about 0.573. To get our Q hat, we do 1 minus our P hat. So we'll do 1 minus 0.573, which will give us 0.427. N is our sample size, and they tell us right up here that N is 946. What we do have to do is find that Z alpha over 2. There is a chart in your book to help you with this, and we find that this is 1.96. So to plug in this margin of error, we do 1.96, our critical value, times 0.573 times 0.427, all over our N. Be careful when you're typing it in your calculator and make sure that 946 is actually included in that square root. Now when I typed it in, I used unrounded values for my P hat and my Q hat, and I ended up with 0.01352170044. You may end up with slightly different numbers if you use these rounded to 3 decimal places, but when we round our final answer, we should all get the same answer. 3 decimal places tells me that that 5 should bump that 1 up, and we'll have our margin of error of 0.032. Now for part C, construct the confidence interval, we have to use our answers from part A and part B to do this. To construct our confidence interval, we take that P hat and we add and subtract our margin of error. So I'm going to take that 0.573 and I'm going to subtract 0.032. When I do that, I get 0.541. Then I'm also going to take that same P hat and add 0.032. When I do that, that gives me 0.605. So if I'm trying to write this confidence interval, I write 0.541 is less than P, which is less than 0.605. Remember, our confidence interval is always trying to draw conclusions about the population parameter, so in this case the population proportion, which is why we use P in the middle there and not P hat. Now keep in mind that you can also do this with your calculator. There's a video on D2L that walks you through it. For this case, you would hit Stat, and then we'd want Tests, and then you'd want option A, which is the 1 proportion, so 1 prop Z interval, because we're using our Z critical value, and we want a confidence interval. When you do that, make sure that you have the stat selected, not the data, and we'll say what our X was, which was 542, what our N was, which is 946, And our confidence level, or our C level, we always need to put that in decimal form. So if we want that 95%, we're going to type in 0.95. When you hit enter to get that, we're going to get 0.54142, comma, 0.60446. So that's another way to write our confidence intervals with those parentheses. And if we follow our directions to round to 3 decimal places, we still end up with 0.541 is less than P, which is less than 0.604. You can use either way on a test. Now, if we look at part D, they also ask us to write a statement that correctly interprets the confidence interval. And we do need to be very careful with the wording. If you look in your textbook, they walk you through some correct ways and some wrong ways to interpret this. The correct wording that we're going to use is that we are 95% confident, and that comes from our confidence level, that the interval from, and we list out the interval that we solved for, so that 0.541 to 0.604 actually does contain the true value of the population proportion P. So essentially, you're going to use the same basic layout. The only things that are going to change is what your confidence level is, the interval itself, and then we'll see sometimes, like in section 7.1, we'll be looking for the population proportion P, and sometimes, like in section 7.2, we'll be looking for the population mean. So just be careful with those. We have one more example from section 7.1. It says, in a study of the accuracy of fast food drive-through orders, restaurant A had 296 accurate orders and 73 that were not accurate. For part A, they're asking us to construct a 95% confidence interval estimate of the percentage of orders that are not accurate. So I'm going to use my calculator for this. I'm going to use stat. Then I'm going to go to tests. And I'm going to choose option A, that one prop z-test. When it asks me for my x, that's going to be the 73, because we're looking for the orders that were not accurate, and there's 73 that are not accurate. My n is the total sample size. So if I look, I have how many were not accurate and how many were accurate. So to find my n, I need to do 296 plus 73. When I do that, I end up with 369. So my n is going to be 369. For my confidence level, they told me that I need a 95% confidence interval, so I put that in decimal form as my 0.95. When I type this in, I end up with, I hit a wrong button. Thanks for your patience. There we go. I end up with 0.15719 to 0.23848. So if I'm writing it and rounding it to 3 decimal places like they typically ask me to, I'll have 0.157 is less than our population proportion, which is less than 0.238. If we look at part B, this is the new part. They're asking us to compare it to a different restaurant. So if we look at this restaurant B, which has 0.183 is less than P, which is less than 0.252, and we're trying to figure out what can we conclude. Essentially, we're looking at, do the confidence intervals overlap, yes or no? And if you're not quite sure what that means, think about putting them on a number line. If we're thinking about restaurant A, right, that confidence interval is from 0.157 all the way up to 0.238. So it would go from here over to here. If we think about restaurant B on that same number line, it starts at 0.183 and ends over here at 0.252. So remember, if we go back to that wording, we were saying that we're 95% that our interval actually does contain the true value of the population proportion. So we're saying with restaurant A, that population proportion could be over here, or it could be over here, or it could be somewhere in the middle. And then same thing with restaurant B. It could be over here, or it could be over here, or it could be somewhere in the middle. We don't know where it is. We're just confident that it's in this range somewhere. So because there is overlap, we can say that we're not confident that there's significantly different percentage of orders. So we could say that neither restaurant appears to have a significantly different percentage of orders that are not accurate. We would say that there was a significant difference if these confidence intervals did not overlap. So if we had one very low confidence interval, and then over on the same number line we had one very high confidence interval, right? And there was a gap in between them where there was no overlap, that's when we would say there was a significant difference.